In the third part of the 777 flight control series, we will operate the rudder of the aircraft. The rudder provides yaw control, and can be operated using 3 different inputs: the rudder pedals, autopilot command, and the rudder trim system. Let's start with the rudder pedals. The pedals move on their pivot axis, with the help of pedal arms. Control rods connected to the arms rotate the jackshaft assembly. The jackshafts move the control rods, connected to the left and right shaft assembly. The rods move to rotate the shaft assemblies. The 2 set of pedals are connected with a bus rod. The bus rod ensures when one pilot operates the pedals, the other side has the same movement. This gives the other pilot an indication of pedal position. The rudder feel and centering mechanism provides the feel force to the rudder pedals. As the pedals travel further, it gets harder to push. And once the pedals are released, the spring force returns the pedal back to neutral. Now let's see how pedal movement results in rudder deflection. The shaft assembly rotation is picked up by the position transducers. The transducers, in proportion to the pedal movement, send signal to the actuator control electronics. The ACE relays the signal to the primary flight computer for rudder movement calculation. The PFC returns the final signal to operate the rudder. The ACE sends control signal to the 3 rudder power control units in the vertical stabilizer of the aircraft. The PCUs are hydraulic actuators and use different hydraulic systems for redundancy. The 777 has a rudder tab connected to the rudder. When the PCU actuators move the rudder, the tab moves along with it. But the tab also has a mechanical rod connections, which deflect them further ahead of the rudder displacement. The mechanical connection is rigged to move the tab twice the distance of the rudder movement. By slipping further into the airstream, the tab increases the overall effectiveness of the rudder. Position transducers on the PCU send the rudder position to the primary flight computers. This allows the computers to control the rudder with precision. Now let's look at the autopilot rudder control. The autopilot function is similar to the pitch command, as seen in the previous elevator chapter. Autopilot computer sends a yaw command to the primary flight computer. The PFC commands the ACE to deflect the rudder to meet the autopilot demand. At the same time, the PFC commands the autopilot computer to backdrive the rudder pedals. The autopilot computer engages the back drive actuator and runs the motor to match the rudder pedals to the current rudder position. Back-driven pedals informs the pilot of an autopilot rudder deflection. Once the autopilot command is over, the actuator clutch is released and the pedals return to neutral. Finally, let's see the rudder trim control. The rudder trim switch in the cockpit is used for trimming the rudder. The trim switch has to be rotated for a nose left or a nose right command. Let's rotate for a maximum nose left trim. The trim switch sends a signal to the primary flight computer through the ACE. The PFC, in proportion to the trim requested, controls the rudder trim actuator connected to the feel and centering mechanism. The actuator moves the rudder pedals. The movement results in deflection of the rudder, just like manual control. The actuator will now hold the rudder in its new trim state. Pressing the trim cancel switch sends signal to the PFC to return the rudder back to 0 degrees. Next chapter of the flight control series will be aileron and flaperon control. Thanks for watching.